Okay, this is 5.6, Parallel and Perpendicular Lines. This lesson is not very difficult at all, especially if you understand section 5.4. If you can write an equation of a line when someone gives you a slope and a point, then you can completely do this section as well. Alright, so let's get into it. First thing you really have to know is that parallel lines have the same slope, because they go up the same amount. So that's what makes them parallel. So you have a line like this, got another line like this. If they're parallel, that means they have the same exact rise over the run, and then they'll never touch, so they'll never cross. So parallel lines have the exact same slope. Perpendicular lines don't have the same slope. They actually have a special relationship with the slopes. It's called negative reciprocal slopes. So if you see one of the slopes is 5/3, then you have to flip it and change the sign, and that's going to give you the slope of the line that's perpendicular. Perpendicular lines are special because when they intersect, they create a 90-degree angle. So that's a 90-degree angle right there, and those are considered perpendicular lines. That will always happen when you examine the slopes, and the slopes are negative reciprocals of each other. If one of your slopes is 1/2, and you're wondering, wow, I wonder what the slope of the line would be that would be perpendicular to that, it would have to be flipping this fraction and changing the sign. That's how you would get the -2. If somebody said, hey, my slope is 6, then I know that the slope of the line that's perpendicular to that would be flipping that over. That's 6, or 6/1, so that would be -1/6. So those slopes would show you that the lines would be perpendicular. Alright, I just want to show you a little bit, tiny bit, with the calculator. You know, if I graphed a couple of lines, these are the two lines that I graphed, y equals 2x, right. You can see the, one second, let's see, my calculator froze up. That was a 2 before it sort of froze up for a second. So hold on one sec. Okay. Yeah, so there we go. So y equals 2x plus 5 and y equals 2x minus 5. You can see the slopes there. Let me see if I can write on it again. I think I upset this thing when I write on it. So that's a 2 and that's a 2. They're both in slope-intercept form. Okay. Well, when we graph it, you can see the graphs, and they look like they're absolutely, parallel. And of course they are. They go up the same amount. They both have the slope of 2. They go up 2 over 1, etc. Both of them have the same slope. Now if I kind of change that a little bit, like I let that one be 2x, but then I flip it. I flip the other one, and I make it, let's say, -1 divided by 2. That's what the reciprocal would be, right? And then x, and then I'll just have it go through the same exact spot. So the b, remember, is the y-intercept. That's where it crosses the y-axis. So they should both hit right there at 5. And those two lines are considered parallel. They actually don't look super parallel, and I think it's probably because of the window. Let me see if I can change the window and make it look a little more parallel. Now that looks a little bit better. If I look at the slope there, or the angle there, that'd be a 90-degree angle. Okay? So, back to our examples. Alright, so what will the problems look like that you'll need to do? They'll kind of have big directions, but the process is not difficult. Write the slope-intercept form of the equation of the line that passes through the given point. So you'll be given a point that I messed up there. So the point given would have to be, let me change that. The point given for this problem would be -2, -3, and they tell you that it's parallel to that particular line. Okay, the way we work these is we say, hey, we know we need a point and we need a slope. So when they tell us that our line is parallel to this particular line, we know that our slopes are the same. So what we do is we just kind of use the slope from this equation, and then we use it in our equation, and we use this point and we write the equation of the line. So it's the exact same thing as section 5.4, where we're given a point and we're given a slope. So we just start, if you want to use point slope form, you can, or if you want to start off with y equals mx plus b and go that route, that'll work as well. So I'll just go y equals mx plus b. So I'm going to plug in the y, so I plug in -3. I plug in the slope, because I know that my slope is 2 if it's going to be parallel to that line. And then the x is -2, and then I'm going to solve for b, like we did before. -4 plus b equals -3, and then I'm going to add the 4 over. So if I add 4 to this, that's going to be 1. Okay? So my b equals 1. My slope was 2. So that means the equation of the line for this situation here is y equals, and we've got a slope of 2, so it has 2x there, and then the b is 1. So then we just say plus 1, and that's your final answer. So we borrowed the slope, we used the point, we wrote the equation of the line. Okay, same thing. This time we're given a point, and we're told that it's parallel to this line, y equals 1/2 x minus 6. Again, when someone tells you that your line is parallel to another line, that means they share the same exact slope. So if that slope is 1/2, that means our slope is 1/2. So the slope is 1/2, and then we just use that slope, and we use that point, and we proceed. Y equals mx plus b. We plug in the point, which is 3. We plug in the slope, which is 1/2. Plug in the x, so that's -4 or -4 over 1, just so that it's a little bit easier to do your calculations here, your computations. So it looks like the 2 and the 4 will cancel a little bit. So let's say that cancels, and that would be a -2. So that gives us -2 plus b equals 3, and then we'll just add the 2 over to solve for b. So we add the 2 over, and we're going to say that b equals 5. So we had the slope, now we figured out the b, and we write our equation. That's our final answer. Y equals 1/2 x, and then plus the 5. Okay? Those are the parallel ones. What about the perpendicular ones? Well, sometimes they'll say, hey, it passes through that particular point, oh, and it's parallel to a particular line. Well, if it's perpendicular to a particular line, then we can grab the slope from that as well. It's just that if it's perpendicular to this line, it doesn't have the same slope. Remember, the relationship is flipping it and changing the sign. So if this slope is 2, then we're going to need to change that. We're going to need to flip it, change the sign. So that means that our slope would be, hopefully you know, our slope would be -1/2. That's flipping it and changing the sign. So we're going to use that, and we're going to use the point for -1. That's going to be our x and y, and proceed like normal. We'll start with y equals mx plus b. We're going to plug in the y, which is -1, the m, which is -1/2, and the x, which is a +4, plus your b. So we cancel the 2 and the 4 again. So that's 2, and we multiply those together. That would be -2 plus b equals -1. And then we'll go ahead and just add the 2 over. So that means that b equals +1. Your final answer would be writing always the slope and the y-intercept. So we would have y equals -1/2 x. And we found out that the b was 1, so we just say +1. Okay? Another perpendicular one, same thing, passes through that point, perpendicular to that particular line. If it's perpendicular to that line, then we're going to look at the slope, and we're going to say, wow, our slope's not -4, but it is the negative reciprocal of that. So we'll flip it. That's -4 over 1 right now. So we'll flip it. We'll make it +1/4. So our slope is that. Okay. The point is given, so it's -4, 5. We started off the same way, y equals mx plus b. We plug in the points, or the point, plug in the slope. So for y, we got 5. For the slope, we got 1/4. For the x, we got -4. And the b, we don't know. We're going to figure it out. So the 4's cancel out. So that's -1 plus the b equals 5. And then I'm going to add the 1. So I've got b equals 6. So I'm going to write my equation now that I know my slope and my b. So I write y equals 1/4 x, and then plus the 6. Okay? Last type of problem that you'll see on this section, and really a lot on the Ames test, so it's not a difficult question, so let's check it out. Determine if the lines are parallel, perpendicular, or neither, and we determine that strictly by looking at the equations of the lines and examining the slopes. So if you look at this equation, the first one here, you just need to zero in on what the slope is. So if you're familiar with slope-intercept form, then you know that the slope is always whatever in front of the x. So the slope is 3. Now, when you look at the one on the right, we can't tell what the slope is because it's not in y equals mx plus b form, so you can't really tell. Okay? So what you have to do is a little bit of work and put it into slope-intercept form first. Sometimes it's 1 step, sometimes it's 2 steps. Do whatever it takes. So we're going to need to add the 3x over to the other side. So if we do that, that will be y equals 3x minus the 2. Okay, can't really combine those at all. So now it's in slope-intercept form. So if you look at this, we can tell the slope is right in front of the x, and they appear to be exactly the same. So slope is also 3. So we're going to conclude that these are parallel lines, just from the equations themselves. We don't have to graph it. We can just tell. Parallel lines. Make sense? Hopefully. Okay, last problem. Let's say same directions. Determine if they're parallel, if they're neither, or if they're perpendicular. So the first one's nice. It's already in slope-intercept form, so we can already tell the slope is 5. This one on the right is not in slope-intercept form, so we have to do 1 step. And that would be to try to get the y by itself, so it's being multiplied by 2. So let's divide by 2. So we divide everything by 2. So that'll cancel out. This will be y equals, now that's 6 divided by 2, so that's a 3, and that's x. And then 8 divided by 2 is minus 4. Okay, 8 divided by 2 right there. Now that means we can clearly tell that the slope of this line is 3. So are they the same? No. So we're going to say neither. That just means the two lines cross, but they don't cross, and form a 90-degree angle or anything. Okay? The one that people miss a lot is whenever the lines are something like y equals 3x plus 1, and then y equals negative 3x plus 3 or something like that. They look at these and they say, oh, look, they're negatives. They're opposite slopes. They must be perpendicular or something. And that isn't what we said. We said that they're opposite signs, and they also have to be flipped fractions. So that'd be another example of neither. Okay. So we should be good on that if you understand those examples.